So we are today going to solve more systems of equations. And we've done that several times this year. You have three methods for solving systems. One of them is graphing. Well, if you look at the system we're going to solve now, it's going to have three variables. If you try to graph it, I got x-axis back and forth, I got y-axis up and down, and the z-axis goes in and out. So we're not going to be able to graph that on a two-dimensional piece of paper, right? So graphing is out. That leaves substitution and the addition method. Bless you. Thank you. Well, even if you did have opposites here, these two are opposites. If you add them up, you're going to have 5y plus z equals 9. That's not going to do us much good either. We'd have two variables. So what we're going to have to start out with is substitution. Start out with substitution. And to do that, you can pick whatever equation you want. Whatever equation would be convenient to get either x equals, or y equals, or z equals. Which equation would you suggest we start with?
The first one.
Probably the first one, right? We can easily get x equals or y equals. So I'm going to number. I'm going to use equation number 1. X plus y minus 2z equals 7. Not too difficult to get x by itself, right? Or if you wanted to get y by itself, you could do that as well. Plus 2z. So what do we get? X equals, that goes away, 7 minus y plus 2z. I'm going to put a box around. What will I do with that?
Plug it in.
Plug it in. We're going to substitute it. And what we're going to substitute it into are the other two equations that we have not used. It doesn't matter which one you start with, but when you go to plug it in, you put it into the other two equations, not the one you already used. Since we used equation 1, we're going to substitute it into 2. Will you double check me here? I don't feel like I'm at my mental best today.
I don't think any of us are.
So is that equation 2?
100%.
And then I also need equation 3, 2x minus 3y plus 2z equals negative 2. Is that right? And remember, we're going to take that value for x and plug it in. So I'm going to take this value for x and put it right here. Be careful with this one. We have negative x. We have negative x plus 4y plus 3z equals 2. But what is x? 7 minus y plus 2z. Right?
Mm-hmm.
So we're going to need to multiply that out. We're going to need to multiply this out. Negative 7 plus y minus 2z, and then I've got the rest of this, plus 4y plus 3z equals 2. Combine the like terms. I have a 4y and a y, 5y. 3z, take away 2z. It's a 1z. It's a 1z. And then I've got a negative 7 here. Do you mind if I add it? So I get it to the other side? And once you have it simplified, put a box around it. There's not really anything else we can do with this right now. Then we're going to do the same thing to the other equation that we have not used. We're going to substitute this value for x right there. So we will have 2x minus 3y plus 2z equals -2. But what's our value for x? 7 minus y plus 2z. Yes?
Right.
So then we're going to multiply it out. 14 minus 2y plus 4z minus 3y plus 2z equals -2. And simplify. And simplify. What do you have? -2y, -3y. 4z and 2z.
6z.
And do you mind if I minus 14 right away? And that'll give me -16. Now I have two equations. Now I have two equations. I have 5y plus z equals 9. I have -5y plus 6z equals. Now what?
Can we add them?
You can add them.
Thank goodness.
What else could you do if you didn't want to add them?
You could substitute.
You could substitute. So at this point, it's like one of the olden day problems. It's like solve a system with two variables. And you can either substitute or add them. This one is already all set up for addition. If it wasn't, you might have to multiply. Remember when you had to multiply the equations by something? You might have to do that. Or you could minus 5y and get z equals and substitute it. But this one's all set up. If we add those up, what do we get? 5y and -5y goes away. Z plus 6z. And over here, -16 and 9. I think it's -7, right?
Yeah.
Divide by 7, divide by 7. Hallelujah. I got z equals -1. Now what?
Now we have to plug z in?
Yeah,
Oh,
what? And you have to go back a little bit at a time. You can't go back to the very beginning. You have too many variables. So I probably would plug it into this one right there. So I have 5y plus z equals 9, but what is z?
-1.
So 5y minus 1 equals 9.
Add the 1.
And I get 5y.
Y equals 2.
So I get y equals 2.
Sarah's just smarty pants.
No, you find x.
And now we have to find x.
Oh my.
Now you can go back to this and plug in. I've got,
Yeah,
so x equals 7, take away, y is 2, plus 2 times z, but z is -1. Oh, what fun! So all we have to do is work this out. X equals 7, take away 2, take away 2.
You're a liar.
7, take away 4. So I get x equals 3.
No way.
So our solution, x is 3, y is 2, and z is -1. That's our entire solution. Look at that, all one problem.
I hope we only have like 2 problems.
I had 3.
Oh.
So, does that make sense?
Yeah, it's a lot, but.
Yeah, it's a lot.
It is. And please work carefully. Try not to hurry, because even one little sign error and you're not gonna get the right down at the end, or you'll get. Do you have questions on any of this? So here's the general idea. Shh. One more time, look. 3 equations. Pick one for substitution. I picked equation number 1, and I subtracted y, and I added 2z, so that I have x equals. Take that equation then and plug it into the other 2 that you haven't used already. So we plugged it into equation 2 and 3 for x and simplify. We got this equation with y and z. We got this equation with y and z. So over here, it's like a brand new problem solving this system. And at this point, you can solve it however you want. This one works out where we can use the addition method. If you didn't want to use the addition method, you could do this. You could minus 5y, and then you could substitute if you wanted. You get z, then you have to work your way backwards. From the z, you plug it in here, the value for z, and get the y. Once you have the y and the z, plug it in back here to get the x. Yes?
You can plug it into both of these?
Yes. You have to plug it into both of these because we have one extra variable now.
Combine the y here and the y here,
Yes.
and then you plug it into the first one?
Oh, do you have to plug it into both of these? You mean the z? No, just one of them. Yeah, I only plugged it into this one.
Okay.
Take your pick. And then once you have the z and the y, then you plug it in back here to get the x value. So a little bit more work because we have 3 variables. Anybody with questions? Are there any questions? I don't remember. I think it's this. I think it's this. Carefully. Carefully.
I know.
Bathroom.
No.
To the office?
Bathroom.
Bathroom, yeah.
I want to